5 minutes. Thank you.
Okay, we'll take the questions together after Hugo's presentation. A difficult act to follow, very difficult. Thank you very much. Thank you, Larry. Beautiful presentation. All right, I'm going to give you a different take. Hopefully. All right. I'll be talking about some of the strategies that Sony has created to handle high dynamic range, especially in the area of live production. I'm going to leave the cinema and the consumer side a little bit on and not well explained. And I'll talk about some of the issues related to the standards of high dynamic range and also the compression of high dynamic range signals, especially for sports and live applications. Sony, probably same as of the manufacturers, we have an internal classification of the qualities and requirements needed for different applications of how we handle video. For example, in the area of cinematography, where these are very large scale productions, the picture quality has to be of extreme picture quality, enormous colorimetry, a very high dynamic range, but knowing that the color grading and the processing of those images are, for the most part, handled in non-real time. Therefore, we have time in our hand to exploit the best of those images. Another type of application is the live application, where, again, these are very expensive productions. We require very high levels of picture quality, but we have no time on our hand. Everything has to be done in real time. There is no such a thing as color grading a baseball game in real time. And other applications that are not as complex or will not demand the same levels of complexities that we have in the other productions, such as corporate videos, wedding videographers, event videography. Again, very high levels of picture quality, but at lower price of production. Then Sony has been deploying specialized devices for each one of those applications. And with that experience of fabricating these devices for each application, we have identified 3 classes of a high dynamic range environment. The file-based production is the non-real time, and this is for electronic cinematography. Sony, we use linear coding. We don't have logarithmic curve in cinematography. We have 16-bit precision in our cinematographic cameras. And this is, we create an ecosystem for grading for movie making. Now, for live production, we require, we have to live with an environment which today is 10 bits. How do we take our high dynamic range capabilities of our cameras and map that onto 10 bits? We require logarithmic curve. And we call that scene referred live, or SR live. Another environment, which is the consumer environment or semi-professional applications, these people may not have resources or even knowledge or experience to handle all the complexities of high dynamic range. The only thing they want, they just press a button and record something that looks high dynamic range. And we call it instant HDR. We've been talking to a lot of end users during these last 5 years, from the very high-end electronic cinematography to all the way to consumer electronics. And we recognize that the curve that for the most part is used for distribution of HDR material for movie making is PQ. The Perceptual Quantizer is a de facto curve for OTT distribution or 4K Blu-rays. Now, in the area of live production, we know that there are only 2 vehicles to distribute HDR to the end users, HLG and PQ, hybrid log gamma and PQ. But the mezzanine master, the production quality that we have in our OB trucks, in the outside broadcast production trucks, has to be very, very high, because the cost of shooting the production, a baseball game, a Super Bowl, is enormous. And that material has to be very pristine, very, very high picture quality. In the area of consumers, consumer electronics basically has adopted hybrid log gamma for creation of HLG programs in a very simple way for distribution over the web, in YouTube. As Larry mentioned, HDR is made up of a number of elements, white color gamut, new gammas, and higher luminance. Now we have a new terminologies. We are now talking about PQ, the Perceptual Quantizer, which is SMPTE standard 2084, originally developed by Dolby. And we have now something called hybrid log gamma, which is a curve developed jointly by the BBC and NHK in Japan. And we talk about optical to electrical transfer function. We take light and we convert it into data codes, OETF. And we have the opposite, which usually is implemented in the TV sets, which is electrical to optical transfer function, from code to light. Okay? It's not only a two-dimensional volume of colors, of the white color gamut, but it's a three-dimensional volume of colors. When we move from 100 nits now to 10,000 nits theoretically, we have now a complete volume of colors that we have never seen before. This is some of the promise that we now see with HDR. Another terminology, very important, is called OOTF, optical to optical transfer function. It's the system gamma. It's the complete transfer function that defines how that light that you capture in your camera is eventually reproduced, the look of the picture in your TV set. Today, we have in the world of HDR, this is your 0.45 gamma that we have in the television camera. And when we used to have CRT, the gamma of the CRT was 2.2. If you multiply 2.2 times 0.45, will give you unity. That would have been complete linear light. But now that we have LCDs, based television, the new EOTF that we have built into the consumer TV set is 2.4. If you multiply 2.4 times 0.45, now you get a system gamma, which is 1.2. It depresses the black signals and the shadows a little bit in order to make up the lack of black response that we have in the LCD material. All right, therefore, OOTF is going to play a very important role in the standardization of the standard for HDR. The recommendation ITU 2020 was introduced in the year 2012. This 2015 was the second revision. And 2020 specifies UHD, ultra high definition format, and also the white color gamut. But it never touched the high dynamic range. Then Dolby made their introduction of the PQ system, or the high dynamic range system, to the ITU, and it was very controversial. And it took us 4 years, a complete study cycle in the analysis by the ITU to produce in 2016 the recommendation 2100. 2100 specifies the two curves internationally agreed to replicate HDR. Now, PQ specifies the EOTF, the electrical to optical transfer function. And it doesn't say anything about what you do in the camera when the production of that content. That was the first proposal to the ITU. The television world said, no way, we're not going to use PQ. We're going to use something which is more television friendly. Then there was a very difficult 4 years of discussions. In the ITU, there are problems that have to be resolved, and usually the recommendations specify one single solution. This was one of the very first cases where there were two solutions to one problem, and we couldn't reach an agreement. And technically, we were running out of time. 4 years is a study cycle, and we had to find a technopolitical solution to this debacle that we had. And The notion, well, we don't agree on the PQ, we don't like HLG, but let's standardize both of them, assuming that we have a common agreement on the OTF. Therefore, the PQ folks and the HLG folks will agree on the look of the pictures. And both signals are standardized in the standard. And we introduce these elements of signal processing in the equations in order the inverse EOTF cancels the EOTF, and we end up with the look of the picture from PQ is equal to the look of the picture produced by HLG. With that agreement, the document was agreed by everybody, and it was released to the outside world. The systems that we have now standardized in HDR, in combination with the 2020 recommendation, talk about 1080p. There is no HDR in 1080i or 720p. The minimum common number is 1080 progressive, or 4K, or 8K. We can go up to 12-bit, and we can go up to 120 hertz. These are the specifications of the UHD world, okay? And progressive only. All right, HLG is a scene refer. It describes the signal as seen or captured by the television camera. It's a relative system. If you're capturing the sunlight or a shot in the outdoors, that levels of brightness, you will never be able to reproduce those levels of brightness in your TV set at home. We make a relative representation of those lights. This is what television is all about. PQ is a display refer, as Larry mentioned. It codes precisely the level of light of the mastering display. And every level of that light has a specific number from 0 to 10,000 nits with a digital value, and that is now inverted by the EOTF in your TV sets. Two different perspectives of how to handle HDR. In PQ, we need metadata because the displays that you use in mastering will have different brightness levels, and you have to send that information to the receiving displays in order that the EOTF at the display uses that metadata to map correctly the levels of the brightness levels of the master display. In HLG, we don't need that because it's a relative signal. All the signals are coded in 10 bits between 64 and 940, and they map very precisely into any any consumer display or distribution display of any brightness level. Therefore, HLG and PQ work very differently from the perspective of how to reproduce brightness. In HLG, brighter displays will be used in brighter environments. We maintain the dynamic range of the highlight is always constant, while in PQ, the images don't get brighter when the displays get brighter. The picture levels will be constant. You simply will expand the level of the highlights. Different functionality of PQ compared to HLG. All right, with that background, let me go deeper in the area of live production. This is a technique developed by Sony, and now it's used in quite a good number of services. The problem that we faced about 4 years ago is that people don't have the resources to create an SDR production and an HDR production separately. They don't have a double truck. They don't want to spend double crew. They don't have double set of cameras. They would like to have a single ecosystem that will simultaneously produce SDR and HDR. That was one of the key requirements. Another requirement, especially during the transition period from SDR to the time in the future when everything is HDR, the camera shaders, the video engineers, they don't know how to shade the cameras in HDR. Their skill set has been honed and perfected shading SDR signals. Therefore, how do you transition those skill sets overnight from SDR to HDR? Therefore, we have to invent a technique that allows us to produce HDR content using the skill set of an SDR environment. Because this is a television live production environment, we need to create this environment as on a scene basis, replicating the normal operations that we have in television. And knowing that that signal is going to be distributed either in HLG or PQ, that's depending on the service supplier. Another issue that we've been asked to tackle is the look and the quality of the images that we create in production in the truck rarely reach the living room, the consumer environment. There are so many obstacles that we have in the transmission of signals today in television that precise, that artistic intent in the truck is lost in transmission all the way to the home. Therefore, is there a way to enable that feature? Well, this is your truck. You have an environment. This truck has multi-viewers, television, a monitor, you have video switchers, servers, character generators. This environment is going to be a 4K progressive or 1080p progressive. And Sony, we are selecting two special mastering curve, S-Log3 and something called HLG Live, which I'll explain in detail in a minute. Then all of the sources in the production, cameras, graphics, character generators, will have to be converted in 709 color spaces, SDR spaces, HD, will have to be converted to the environment of the production truck. The production truck is 2020 color space. We have this special curve, and it can be 1080p or 4K. Once you finish your production, then you have to convert for distribution. You have a mastering format here that has to be communicated to the masses, and there are only two ways to do this, HLG or PQ. There are only two taxis that I have to use to get to my consumer TV set. Therefore, we have an EOTF conversion as well as HDR to SDR conversion process that could take place right at the output of the production truck. How we are going to achieve this SDR, HDR? Well, in Sony devices, in the high-end studio cameras and supermotion cameras that we make, we are capable of producing simultaneously SDR and HDR signals, and HD and 4K, 709 and 2020 signals simultaneously. Then these camera control units have multiple brains, multiple processing, which allows us to create simultaneously all of these signals out of the CCU. But the shading, the actual control of the look of the signal is done by processing the SDR level of the signal, not the HDR, okay? Because that truck has to produce an SDR program with the same quality and expectation that we have today. You pay your bills with the quality of that SDR. If you do your production perfectly in HDR and you sacrifice or you jeopardize the quality of SDR, you don't get paid. Then in the truck, we also have a universal HDR converter that allows us to do a spatial resolution conversion, a gamut, color gamut conversion, SDR to HDR, vice versa. It can handle 2 channels of 4K or 8 channels of HD. And we will use this converter to produce these up conversions and down conversions before and after the mastering process. We have our own monitoring devices, trying to, as much as possible, help in the production of that mezzanine master. This is our X300 OLED monitor. And we have also rack-mountable, this is 1080p, these are 4K. And we have a device that has 4 independent processors, allowing us to reproduce simultaneously SLOG3, HLG, PQ, SCR for final evaluation of the environment. But these devices have not only capabilities to show SLOG3, HLG, PQ, it has also a special signal called the live HDR. It's a look, it's an OOTF. These devices, I'll show you in a minute, will inject that special look in the mezzanine master. Therefore, the production, before you begin doing your baseball game or your football game, you adjust. The production is going to be done in HDR, 4K or 1080p, and the video shaders are going to be looking at the SDR signal. Okay? The selection of that curve in the HDR. We couldn't use PQ because PQ requires metadata. And if something you don't want to use in production is to have multiple sources, each one having different metadata. Therefore, we had the option to use HLG or our own curve. The S-Log3 is a special curve designed by Sony that best matches our sensors. These are scene refer, and this is display refer. Now, this curve, originally born in the area of cinematography, was designed to support up to 20 stops of dynamic range. We don't have cameras that have 20 stops of dynamic range. Therefore, we will be using this logarithmic curve into the future. And it's designed at the moment to support mapping of high dynamic range onto 10 bits. But it has a very interesting characteristic. This axis is incoming light. This is display or output light. And this red light is the theoretical PQ OTF that can reach up to 10,000 nits. This dotted line is HLG, which is at about 1200%. This green curve is the PQ. The important behavior is between 0 and 100 nits. PQ, the S-Log3 mimics the 709 gamma in that range of light. Therefore, by basing our mastering format in the truck using S-Log3, we can down-convert that HDR master to perfectly produce an SDR signal because it behaves in that range like a 709 signal. Then, just going fast here, if you turn on the camera, your HDR signal and your SDR signal will look the same because you haven't misadjusted them. But if you open the iris of your camera and your HDR becomes brighter and brighter, your SDR is going to clip. Then at that point, we introduce a differential gain between the processors of HDR and SDR. And we lower the SDR so that the SDR looks perfect and your HDR looks perfect. And at that point, you lock that number. This is called the differential gain number. And then you forget about the HDR. You just simply shade your camera looking at the SDR monitor. Okay? And we can extend that range of the SDR capabilities by introducing a hypergamma or a cine gamma curve. And interesting thing is how you expose that HDR camera in order to position faces and the mid-range tonality properly within the HDR. Remember that SDR and HDR look the same at 100 nits, 200 nits. It's only the highlight that differentiate one versus the other one. Then this is, companies are testing this. There's a lot of operational guidelines. And recently, about last year, at the end of last year, there is an operational guideline recommendation from the ITU. It's recommendation 2408. That recommending how to expose PQ and HLG, and we are telling the video engineers using your waveform monitors, these are the nit values and these are the IRE units that you will see in your waveform monitor in order to produce properly diffuse white, graphics, skin tones. Again, a very important document to read for live production. Another function that Sony is introducing is how to convey the rendering intent. Rendering intent is the look, the quality that we decided in the truck can be transmitted all the way to your living room, assuming that your transmission path is correct, there's no failures in the satellite. And once again, I remind you of this OOTF and OETF. If I were to use HLG plain vanilla, just by the standard in the ITU recommendation. Okay, I have my CCU of my camera. I connect the OETF from the output of the camera, connect it to my monitor. And if I now connect this to a consumer TV set, the HLG is going to look okay, but not very punchy, not really contrasted. Then the video operator will tend to open the iris by one stop to make it look really popping. But when you do that, you're going to cut the range of highlight that you will be able to achieve with HLG. Then what we've done with S-Log3 was to inject a special look in the display that this look, now we wrap it on the signal processing of HLG, knowing that the TV set at home will unwrap that signal processing, and the look that we create in the truck appears in the consumer set. This is the combination of the HDR converter along with the processing in the camera. Okay? Then, a lot of detail. Okay. We've done a lot of testing on this, and we have been able to achieve the look that we have in SDR and HDR in the truck now appears all the way to the transmission path perfectly. Then we have done a lot of testing and events around the world, dozens of during the last 4 years. And last year, we managed to do the finals of the European Football League, which gave us the right to do the World Cup. Then coming up in June, the World Cup is completely done in HDR. Using, we have about 40 cameras per stadium. There are 12 stadiums in Russia. And it uses dual layer. There's going to be a base layer of SDR, supplemented by a layer of HDR. And the HDR is 3840 by 2160 S-Log3. All of the cameras will be operating in S-Log3. The output of the stadiums will be in S-Log3 in 4K, and there will be the layer of SDR simultaneously, so that a single operator operating the video switcher will apply the same effect to the two layers. Okay? We've done this with S-Log3, and in the US, we are doing the same thing with something called HLG Live. We are adding the effect, the look, the punchiness that we created in S-Log3 now with HLG in order to provide the same effects that we had in S-Log3, but now using HLG. All right, therefore, this is what we have out of our devices. Graphics, we are not asking people to do all of the SDR graphics replicate them in HDR. There's a recommendation, just increase your 100% white that you have in SDR by 6 dBs and add that to your HDR production, and everything will be okay. Another very important technique that is happening in Europe and in Asia, what's happened when you mix SDR programs with HDR programs? The TV sets, all of them have HLG and PQ curve, and SDR curve. But it will take 3 seconds, 10 seconds for that EOTF in the TV set to switch. Therefore, if you have a playout server in your television station, and you have an SDR commercial, and then you switch to an HDR program, how do you tell the TV to switch so fast? And in Japan and in Korea, we have developed a technique to disguise the SDR signal into the HDR channel so that there is no switching of the TV set at home. And this is called a display refer commercial or a display refer program. Therefore, we maintain the look of your SDR program all the way from origination, but it's presented in an HLG signal in your TV set. Okay, I have to wrap up. Okay, all right. Yes, we're going to have this slide. All right, we have all the tools. Watch out about compression of HDR signals. Very, very difficult to achieve, and it's an area that could create a lot of problems if it is not done properly. We have the tools. Thank you very much.
Thank you. So